Hello friends and DIYers, welcome back to the DR100W concept project microcontroller programming section, and you are watching episode 3. In this video, we will take a look at the 20x4 LCD, which serves as our human machine interface, or popularly known as HMI. It is a powerful means of communicating to the user. Let's dive to that after my intro. One of the primary reasons why myself and my friends who made this project is to demonstrate to our fellow hobbyists the use of HMI, or the Human Machine Interface LCDs, where our project, the DR100W concept, it's a Class D power amplifier, will communicate to the user using a nice and big display, as well as an alert sound like a beep as a confirmation of a command, like pressing a switch. And here we go. We have the 20x4 industry standard LCD or liquid crystal display. For now, we only take a look at the simulation while our hardware is being built, or maybe it's on the way to our home. For this reason, I will not be discussing the 20x4 LCD hardware interface. I will reserve this when we are into the real hardware environment. What we will do now is to dive into the LCD programming using BASCOM 8051 LCD library, and let's do that. Our program will look like this. The LCD configuration is reserved for the real hardware interface. We can ignore it for the time being while we are in the simulation, but I reserve it here in the program for the control bus and data bus for a reason that it will be easy for us to migrate from the simulation point of view to the real hardware environment. The next couple of instructions is a standard LCD initialization. The LCD initialize is to wake up the LCD to ready for operation. Turn off the cursor so that it will not be seen on the screen blinking. Display on to put the module into the active mode. The following instructions are for LCD controls. CLS is to clear up the LCD. It means to clear any residual display during the wake-up process or reset process. The locate instruction is to specify the exact location of displaying on the XY plane. The Y plane is the vertical with 4 rows, and the X plane consists of 20 characters including space. All in all, you can display a single character on an XY plane with 80 locations. That is 20x4. Once you identify the location where to display the character, you can now display the information like welcome to Baguio. Easy, isn't it? By the way, Baguio is my city. It's a lovely city situated on the mountainous area about 1,500 meters above sea level, of course in the Philippines. I can add program 04 to get the program running to blink all the 8-bit ports of port 3. For that reason, I can choose to add another information which is like this, blink P3 using byte command. I can display that on the LCD. And there you are, the program has been completed. Let's simulate it. Our concentration now will be on the LCD emulator for the character to be displayed, and the other one is the port emulator for port 3, as well as the control and data bus on port 2. As usual, press F7 to compile the program, press F2 to enable the simulator, and then press the LCD icon to enable the hardware emulator. And there you go, you got the display and the program is running on the simulator. As usual, always consult the BASCOM reference manual for the LCD simulation. It will teach you more than I can do. Thanks again to Mark Alberts, the designer and owner of BASCOM 8051 IDE, as well as the BASCOM AVR. Now, we have a better way to communicate to our program. Even though it is only on the simulation, we can appreciate what our program can do, can see the program flow, the logic, and overall, we can improve our microcontroller programming skills. The good stuff is, it's free. What is next? We can play around by writing more display like a blinking message to emphasize what we want to say to the user, or simply something that we want to practice on several instructions and use the LCD display to inform us of what is happening, like counting a number, increasing from 1 to 100 using the 4 next command. I am going to show you some real-world display using the 20x4 LCD in the DR100W concept project. These are real-world hardware environment taken from the project. Let's just take a look at it, and it will give you an idea how you design your own MMI later, the man-machine interface of your own amplifier. I'm going to show to you some real-world display using the 20x4 LCD that was implemented in the DR100W concept project. These are real-world hardware environment taken from the project. Let's just take a look at it, and it will give you an idea how you design your own MMI, the man-machine interface of your own amplifier. To press this button. Watch this one. If I want to access the turbo bus and the 3D sound, I have to go inside the menu. That is for the setting the turbo bus and the 3D sound. This is the turbo bus and turbo bus off, 3D sound and 3D sound off. Alright, if we're going to power off the unit, what we can see on the LCD is it's powering down now, decreasing the volume. And the DR100W concept guys who developed this project, well, my name is there at first. We got Ariel, Brian, Rommel, Anna, and Noli. We called ourselves the DR100W team. Well guys, this is the end of episode 3. I hope you learned from it and benefited for watching my free tutorial. Kindly support my channel by subscribing to keep me here at YouTube. Share it to your DIY audio hobbyist friend and for anyone who like to start up to learn the microcontroller programming. Bye for now and see you in the next video.